So we're actually going to go backwards a little bit, and since we're done with elimination and substitution, we're going to go back to 5.1, which is compound inequalities. I group these sections a little differently because I feel like these ones go together better. We'll do like 5.1, 5.7, and so on. These ones just kind of go together a little better. But before we get into compound inequalities, we want to go over what an inequality is and how you graph one of them before we get to a compound one. So hopefully you remember, if you see less than or greater than, that's open circle or dashed line if we're drawing on a coordinate plane. If you see less than or equal to or greater than or equal to, that's a closed circle or a solid line if you're graphing it on a coordinate plane. But right now we're just going to talk about number lines. So how do you graph x is greater than 5? You have to number this, and you can put 5 wherever you want. Just know which way the numbers go. And you would start at 5. Since it's no underline underneath it, that means it's an open circle. And numbers greater than 5 would be shaded to the right. So I'm just going to do, I think, a highlighter on it. It looks something like this. Next one, w is less than or equal to negative 2. Put negative 2 somewhere. Negative 1, 0, 1, 2, so on. This is just a quick refresh on how to do this. You put a closed dot at negative 2. Make sure it's filled in. And then I would shade numbers that are less than negative 2 would go this way. Also, if you just look at the less than sign, it looks like an arrow to the left. They kind of correspond to the same thing. So long as the variable comes first, you're allowed to do that. Look at the less than sign and shade to the left. Part C is a little backwards, so I would rewrite this, and instead of saying 4 is greater than z, I would flip it around and say z is less than 4. And so if you put 4 somewhere here, less than 4 would be to the left, and it's open circle, and you would shade to the left, just like we did the last one. So long as z, or the variable, is first, you're good. Last one, again, I would flip it around. 8 is greater than or equal to g. If you flip that around, the sign switches as well. G is less than or equal to 8. So you go 8, 9, 10, 11, 7, 6, 5, 4. And then it's less than means you do less than or equal to means a solid dot at 8. Less than or equal to, shade to the left again. Here we go. And notice I'm putting these right on top of the graph, not above it, but actually on the graph, on the number line. Okay, so now we can talk about compound inequalities, where we're going to put two of these together. So how do you graph compound inequalities? So what is a compound sentence? A sentence where two clauses are connected by either the word and or. So we're going to discuss, what these two mean in the context of math. That's what makes it a compound sentence. So we're going to be connecting inequalities with the word or the word and. We'll do some simple examples. The first one is called the or word. They also call that the union. So this is whenever you have two sets of numbers and you list out all the numbers with no repetition. A union means you put both sets together, like a reunion. Your entire family gets together. So they also use this symbol right here. This is the union symbol in the middle here. Looks like a U, if you can kind of see how closely they look. So if I'm doing the union of these two sets, that literally means everything from this set and everything from this set go together. It's like a family reunion. Everything from your one side of the family, everybody on the other side of the family, they all get together in one big set. Union means let's put them all together. So we don't have to repeat, though. So you see how 1 repeats in both of them? Just put 1. What else do we have? 3, 4, 6, 7, 10. That would be a union. That's what that symbol means, union. The other word, so that was or. If you see the word and, that means intersection. So in two sets of numbers, it is what each set actually has in common with the others. Again, you don't need to have repetition. If I'm going too fast, you can also pause the video. I'm trying to get through this lesson fairly quickly, so it doesn't take too long. So the intersection actually looks like the same symbol of the U, but it's just flipped upside down. So this means intersection. So what is the intersection? Well, it's whatever they have in common. So what are the numbers they have in common here? 11 and 7. I believe that's it. So you would say 7, 11. Make sure you put curly brackets around the set. That would be the intersection between the two, wherever they overlap or what they have in common. So now we're going to apply it to inequalities. Graph the following compound inequalities. So we have 4 is less than x, and x is less than or equal to 8. I'm going to rewrite this one because I don't like it written this way. This is going to be x is greater than 4, if you flip this around, and x is less than or equal to 8. Okay, so I'm going to graph these separately on these two lines, and then we'll find out what the intersection is, because that's what the word and means. So let's do 4, 5, 6, 7, 8, 9, 10, 11, 3, 2, 1. So I'm going to do an open circle at 4. And which way do I shade? If it's greater than, that means we shade to the right. The next one, we'll do x is less than or equal to 8. So that's what we're going to do down here. So we have to go, I'm going to use the same number line too. I'm just going to copy the same numbers down from above. Whoops. 6, 5, 4, 3, 2, 1. So this one starts at 8 less than or equal to. So that's going to be a solid dot here. Less than would mean we shade to the left. So that'd be all these numbers here. And so to actually answer this question up here, the original question, if you're going to be greater than 4, but also less than or equal to 8, that's where they overlap. So if you look at our two graphs here, where do they overlap? If we use the same number line down here, again, 5, 6, 7, 8, 9, 10, 11, 3, 2, 1, wherever they overlap. So if you look straight down here, 4 is not included here, and it will not be included down here because they don't overlap here. But all these other numbers in between here, right, they all overlap up to and including 8. So wherever they overlap is what I draw. That would be from 4 up to 8. 8 is included, 4 is not included, and we shade in between them. That would be the answer for example 3. So I'm only looking for where they overlap because of the word and. And means intersection. All right, B. I'm going to do the same thing. It's going to be less than 12 or greater than 65. Probably will go by 5s, maybe. 10, 15, 20, 25, 30, 35, 40, 45, 50. May not be able to do that either. No, I'm not going to be able to do that either. I'm probably going to go by 10s then, which will make this kind of short here. So I'll start with 10 here and then go by 10s here because I need to have 10, 12 and 65 on the line. So 30, 40, 50, 60, 70. That should be all we need. Copy down for all of them. Okay, so now I'm going to graph each one individually. We'll do A is less than, not equal to, just A is less than 12. We'll have to estimate it. It's an open circle at 12, so it's going to be probably right around here. And less than means you shade to the left, like this, with an open circle. The next one is A is greater than 65. So we start at 65, open circle, about halfway between 60 and 70. Greater than means all the numbers to the right of it, all the bigger numbers. Okay, so this word here is now or. So that means you can be a part of either one. Remember the union, they come together. So you have everybody from this set, you have everybody from this set, and we put them together. So it doesn't matter if they intersect or not, you include them both. So down here, we're going to copy this one down and copy this one down. It does not matter if they intersect, if they don't intersect, it doesn't matter. So it's going to be open circle, shade to the left. This one will be open circle, shade to the right. Just now on one number line, like this. So that would be the answer to the original equation, or the answer, or compound inequality. Okay, there's a team huddle you can do to try them. There's only 4 of them. We're going to move on and do the second part of the lesson, and then we'll be able to wrap it up. So we're still going to use inequalities, but now we're going to do some solving of equations. So when you multiply or divide both sides by a negative number, when you have inequalities, you have to remember to flip the sign of the inequality. So I skipped the huddle for a little bit, so just make sure you know what I'm doing here. So I flipped the sign of the inequality. Only when you multiply or divide both sides by a negative. So for instance, if we have 2x is less than or equal to 10, and you want to get x by itself, what would you do? You would divide both sides by 2. Right? Does anything happen with the inequality here? Nope. No negative signs that we're dividing by, so it just becomes x is less than or equal to 5. Part B, we have z divided by negative 3 is greater than 8. If we want to get rid of the negative 3, we would have to multiply, in this case, both sides. So I'm just going to put it down here. We would have to multiply both sides by negative 3. And as soon as you multiply by a negative, right up here, if you multiply or divide both sides by a negative number, you have to flip the sign. So this sign in here will now become a less than sign. These cancel out. So z is less than 8 times negative 3, which is negative 24. And that's your answer. All right, I got 2 more here. X plus 8 is greater than or equal to 14. We're just keeping this and treating it as if it's an equal sign. The only difference is you have to change the sign if you have a multiplier divided by a negative. So this one's just simply subtracting by 8. And does subtracting by 8 make a difference as whether or not you change the sign? It does not. It stays exactly the same, and that would be 6. Stays the same when you subtract. All right, part D. 4x minus 6 is less than 18. I would add 6 to both sides. So you get 4x. Does that change the sign when you add? Absolutely not. This would be then 24 divided by 4. X is less than 6. Does it change to a greater than sign? No, we divide it by a positive number, so it's okay. Only if it's negative. Okay, the last one we're going to do is we're going to go backwards and look at the graph, a number line, and try to write the inequality. So it says write an inequality for the set of numbers graphed to the right. So you can pick whatever letter you want. If you want to use x, that's fine. We'll say we're going to do these pieces individually. So we'll say x, let's do this one, all from 3 down, so 3, 2, 1, 0, negative 1. So we want to say x is going to be less than 3. Do we put equal sign there? Well, just look at the open circle. We would not put an equal sign because it's open. All right. And then the other piece we have, I'm not going to put the word in between. They're going to put and or here. Then we have x is, well, we have 6. We just have to know whether or not it's greater than or less than. So 6, 7, 8, 9, these numbers would be bigger than 6, so it's greater than. And since it's filled in, it's equal to. Now, is this an and or an or? Now, remember, and means where they intersect. So do they intersect at all? No, they don't. So clearly, if this word was and, there would be no intersection, there would be no graph. So because we included 2 separate pieces like this, this has to be the word or, a union between the 2. Hopefully that's enough examples to finish the huddle, and you'll need to then send me that as well for the huddle, both huddles, and the mastery. So there's quite a lot of problems to do that's left, and hopefully you can finish those and send them to me. And that'll be all for 5.1.